All right, here's just a couple of examples of balancing equations. I'll just do a couple. So say I've got something like this. I've got sodium, and let's react that, say, with lithium chloride. Maybe that's not the best example. Okay, when you react that, sodium is usually a positive ion. So it's going to, if this is a single replacement reaction, it's going to replace lithium that is also a positive ion. And chlorine's a negative. So this positive is going to go with the negative. So it'll form sodium chloride plus lithium. Now, not a good example, because to balance this, what I need to do is I need to make sure there's the same number of atoms on the left side of the arrow as there is on the right side. So here I just have one sodium, and on this side I have one sodium, one lithium, one chlorine, and I only have one of each of those on this side too. So I didn't really have to balance anything. Let me make up another question. Okay, let's do a double replacement reaction. So why don't we do copper sulfate. We'll do copper 2 sulfate, and let's react that with sodium chloride. Okay, and this is a double replacement reaction. So copper, because sulfate is a 2 minus ion, in order for this to be balanced so that there's just one copper and one sulfate, copper also has to be a 2 plus ion. Okay, and on this side, sodium's 1 plus, chlorine's 1 minus. So the copper is going to go with the chlorine. So I have copper and chlorine. Now the copper was a 2 plus ion, and chlorine is 1 minus. So to balance just this compound, I need 2 chlorines. So CuCl2 would be the proper formula for that. Plus, then I've got sodium that is going to go with the sulfate. So sodium is going to go with the sulfate. Sodium is a 1 plus, sulfate is a 2 minus. So in order to balance this, I need 2 sodiums. So if I have 2 sodiums, then it's going to be this total here. Since there's 2 of sodiums, I'd have a total of 2 plus charges there. Okay, so now I've written out my chemical equation. Now I need to balance the whole thing. So this is where I'm looking to make sure I have the same number of atoms on the left side as I do on the right side. Some people, what they do when they balance, they'll put the compounds or the elements in the middle. So I have a copper, I have a sulfur, an oxygen, a sodium, and a chlorine. And they'll just sort of count to how many of each they have. So on this side, I just have one copper, and on this side, I have one copper. Hey, those are balanced. I have one sulfur, so one sulfur, and on this side, I've got one sulfur. This is good. I have 4 oxygens. On this side, I also have 4 oxygens. Life is good. Sodium here, I have 1. Good. Sodium on this side, I have 2. Got to fix that. Chlorine on this side, I just have 1. Chlorine on this side, I've got 2. I've got to fix that. Okay, so in order to fix that, or to balance the reaction, I'm looking to put a number in front of there, or there, or there, or there, in order to make sure the numbers balance out. Now, since there's 1 sodium on this side and 2 on this side, it makes sense for me just to put a 2 there. And let's see what happens when I do that. The 2 here applies to everything in that compound. So it would mean I have 2 sodiums and also 2 chlorines. So when I take a look at things now, it looks like everything is balanced. So that chemical reaction is balanced. Another one that's fairly easy, because all I had to do was put a number in front of 1. Let's try another one. Let's burn ethane. So ethane, C2H6, and let's burn that in a combustion reaction. And combustion always produces carbon dioxide and water. And I want to put numbers in front of one of those in order to balance everything. Again, I can look and say, well, here I have carbons, I have hydrogens, and I have oxygens. That's all that I have in those compounds. Here, from this compound, I have 2 carbons. Over here, I only have 1 carbon. Here, I've got 6 hydrogens. And on this side, I only have 2. This side, I've got 2 oxygens. This side, I've got 2 plus another 1, so I have 3. So you see, all of these are are out of kilter, and I need to balance them somehow. Let's maybe start with the carbons. So here there's 2, and here there's only 1. So why don't I put a 2 there? If I put a 2 there, that'll make 2 carbons on each side, which is good. But it also gives me more oxygens. So there's 4 oxygens now on this right side. Oh, hold it. There's 4 plus another one, so it's 5 altogether. And on the left side, I have 2 oxygens so far. But that's an odd number, eh? I guess I could put a half in there, but that's sort of bothersome. Well, maybe let's balance off the hydrogens and see what happens there. So there's 6 hydrogens here. There's 2 here. What if I put a 3 in front of there? That'll give me those 6 hydrogens, right? But then that messes up my oxygens, because now I've got 2 times 2, that's 4, plus another 3. Now I've got 7 oxygens. And on this side, I only have 2. So what could I put in front of that? I guess I could do a fraction. If it makes sense for you to say, well, why don't I put a 3.5 there? If you take 3.5 and times by 2, I think you get a 7. So that would actually balance that chemical reaction. The other thing you could do at that point, if you don't like dealing with decimals, is you could just double everything. So let's put a 2 here. And maybe let's just erase what I have down for these right now. And it's okay if you want to put the CHO down there, but you'll find that fairly quickly you'll get so that you can just sort of take stock of what's in the reaction and be able to sort of go, just follow the bouncing ball to see how many things you have. Let me try that with just this one. So if I put a 2 there, 2 times 2, that'll give me 4 carbons. So I need a 4 carbon here. Hydrogens, 2 times 6, that gives me 12. So over here I need to put a 6, because 6 times 2 also gives me 12. Okay, now let's look at oxygens. Here I've got 6. 4 times 2 is 8. So 8 plus 6, that gives me 14 altogether. So therefore right here I put a 7, and now my chemical reaction's balanced. Let me just try maybe one more. Okay, let's try something like this. Aluminum hydroxide. And let's react that with, let's go sulfuric acid. Yeah, that should work. Okay. So when I write the reaction, this aluminum is going to hook up with the sulfate. So aluminum and sulfate are going to get together. Now aluminum is usually a 3 plus ion. Sulfate's a 2 minus. So when you do the, try and balance that, you probably need 3 or 2 aluminums. If you have 2 aluminums, and if you have 3 sulfates, just look and see if all the charges balance now. So 3 plus and 3 plus will give me 6 plus, and those are going to give me 6 minus. So I need 2 aluminums, and I need 3 sulfates. Let's put a 3 right there. Okay, that's good. So I've got the formula for that one down. And then, so this went with this. Now this goes with this. So hydrogen goes with hydroxide. And hydrogen's a 1 plus and OH is a 1 minus, so those are balanced. And HOH, as you probably know, is just water. I'm actually going to leave the water, instead of writing it as H2O, I'll leave it as HOH, because it's useful to be able to identify or treat this group together. Rather than treat it as one oxygen and two hydrogens, I'm going to treat it as one hydrogen and one hydroxide, because on this side I also have a hydroxide. Okay, so now I need to balance this. So here I've got aluminum, there's only one. Here there's two, so I need to fix that. So let's put a 2 out front of here. Okay, so that gives me two aluminums, and here I have two aluminums. Aluminums are good. But by putting a 2 there, 2 times 3 gives me 6 hydroxides. Over here I only have one hydroxide. So if I put a 6 in front of that, that'll give me 6 of the hydroxides. But that also gives me 6 hydrogens. So over here there's a hydrogen. If I put a 3 in front of that, that'll give me 6 hydrogens. So those will be balanced. But then that also gives me 3 sulfates, which over here I have already. So I'm balanced. That's a nice example of a double balancing a double replacement reaction. Hopefully I gave you 2 or 3 good examples of balancing chemical reactions and just what's going on in your head to try and figure things out. Notice that a number out front applies to everything inside, but if I have a number in the back, like this 3 there, that 3 only applies to the sulfate. It doesn't apply to the aluminum, just to the sulfate. And here this 2 only applies to the aluminum. Here this 6 would apply to each of those things beyond it. Okay.